For these three examples, we're going to practice adding and subtracting polynomials. So for number one, we have the sum of two trinomials, and essentially you don't really need the parentheses because there's no number in front of the parentheses to distribute. So I'm just going to rewrite this without the parentheses in the very front. So we have a list of 6 terms, so we're going to be combining like terms. So 5x squared plus 4x squared is a total of 9x squared. Combining the x's, I have 2x's minus 8x's, so 2 minus 8 would be negative 6x. And then lastly, combining the constants, I have negative 3 plus 5. So negative 3 plus 5 would be 2. Notice that I wrote my answer in standard form, highest degree to lowest degree. So it goes x to the second power, x to the first power, and then a constant has a degree of 0. So for subtracting, there is something you need to do with that subtraction symbol. The first trinomial doesn't have a number in front to distribute, so I don't really need the parentheses. But you're subtracting all 3 terms in the second parenthesis. So since you're subtracting all 3 terms, you are really distributing a negative 1 to all 3 terms. So if I distribute a negative 1 times 4x squared, that becomes negative 4x squared. When I distribute a negative 1 times 3x, that becomes negative 3x. And then double negatives here, when I distribute negative 1 times negative 15, that becomes positive 15. So we're back to combining like terms. So 10x squared minus 4x squared would give me 6x squared. Combining the x's, I have negative 8x minus 3 more, so that would be negative 11x. And then lastly, the constants. So I have 1 plus 15 more, so a total of 16. So again, I made sure that my answer was written in standard form, highest degree to lowest degree. So for number 3, if you look at the polynomial here that we're going to be adding together, the trinomial plus the trinomial, you could think of this scenario of adding both of those trinomials like adding 3-digit numbers, 324 plus 235. So if I add those together, I would get 559, right? So we're going to show that this sum here really represents the sum of those 3-digit numbers. So if you let x equal to 10, technically, if I plug in 10 for x here, 10 squared is 100, right? Times 3 is 300. Plus, if I do plug in 10 here, 10 times 2 is 20. And then plus 4. So that first number is really 324, right? And if I plug in x into the second trinomial, if I plug in 10 for x, 10 squared right here is 100 times 2 is 200, plus 3 times 10 is 30, and then plus 5, so that's 235. So essentially, this shows the sum of both of those 3-digit numbers. So let's add these together by combining like terms and see how it is represented as our answer here. So 3x squared plus 2 more would be 5x squared. 2x's plus 3 more is 5x's, and then 4 plus 5 is 9. So this would have the exact same answer if you plug in 10 for x. So if I plug in 10 for x right here, 10 squared is 100 times 5 is 500. If I plug in x right here, 10 times 5 is 50, and then plus 9 more is the exact same answer of 559.